Here we will demonstrate how to use Altair HyperWorks FEKO for characteristic mode analysis. First, let's open a new project and save this project. We will call it Altair HyperWorks FEKO Demo. Our units for FEKO are found in the bottom right-hand corner. We can click on this and change it into any units. Let's leave it as meters and create a new variable. Let's name this variable length and have it as 136 millimeters. If we create this, it will close the dialog box. If we add it, we can add another variable. Let's add the variable width and make it 66 millimeters. Now we have our length and width variables. So let's create a new object. In the Construction tab, we have 3D objects and 2D objects. For this demo, let's do a 2D rectangle with size starting at length and width, with a total size of length and width. Let's name this object Object 1. And once again, if we say add, we can add multiple objects, or create, and we will finish with this. We can zoom in using the scroll wheel and click to rotate the object. We have here a perfect electric conductor. We can see that by selecting our object, going to face, and double clicking. We can see the default is actually a perfect electric conductor, but we can also select that. Here you can also define custom meshing objects and solution types. Additionally, if dielectrics are needed to be added, you can add dielectrics under the Medium tab. Now we have our object, and we need to define what type of solution we are going to request. So we want to request characteristic modes, and let's request 6 characteristic modes and create this. We can see our configuration change it to characteristic mode configuration, and if you want to change the number of characteristic modes, double click on your requests and you will see it here. Now let's define our frequencies. We can do a single frequency, a continuous, linear space with discrete points, or a variety of others. Let's do linear space with discrete points and start with a frequency in hertz of 0.8 gigahertz and end with 1.2 gigahertz, with the number of frequency points being 21. We can say OK. And now we have 21 uniquely defined frequency points, which we will define our solution over. If you have multiple objects in your geometry, under our Construct tab, you would want to select both of them, and under Construct, you need to union them, and that will define them as one object. Now that we have our characteristic mode solution that we've defined, our object created, we must also request different entities which we want to view. So here, let's look at a 3D far field pattern. We can click on the 3D pattern and it will automatically insert the data. Let's do 10 by 10 and create this. Let's also request near fields. Here we can start at the top edge of our object by saying minus length divided by 2, minus width divided by 2, and a height above the object of 5 millimeters. And let's end it at length divided by 2 and width divided by 2 with the same height. Now we need to define the number of points which will be sampled across our near field sampling. Let's do 10 points in this X direction, and let's do 6 points in the Y direction. This is anything you want to define it as. If you have multiple z height values, you would want to define more than one z discrete sample points. Let's create this. Now we both have a far field and a near field that we can view. Finally, before we solve for this object, we need to mesh it. Let's create the mesh, and we can create a fine, standard, coarse, or define a custom. Here, standard is just fine, and we need to mesh our object. We can see the mesh here. If you want to mesh it more densely, you can say fine and mesh it. We'll mesh it more densely, or define a custom mesh, depending on your needs. Finally, let's save this and solve it. We go under the Solve tab, and we need to run FEKO Solver. The solution has now finished, and now we need to run post-FEKO to view our solution. With post-FEKO open, we can now look at different entities. Let's first look at a Cartesian plot of our characteristic modes. We can see our first characteristic mode is this, and our second characteristic mode would be this. Here are our 6 characteristic modes. For each of these modes, we can define a quantity, either eigenvalue, modal significance, or characteristic angle. We can add a marker through the measurement cursors, and we can see that a mode is resonant at a characteristic angle of 180 degrees. For in this case, it is resonant at 0.97 gigahertz. In the 3D view, we can add our near fields by clicking and dragging and see our near fields above the object that we selected. We can look at the electric near fields or the magnetic fields in the X, Y, or Z planes. We can also look at the phase of any one of these. We can change the phase. Additionally, we can plot it in dB and change visibility filters, cut planes, and things of that sort. Additionally, we can view the far field patterns we created by either utilizing this window or creating a new 3D window and sliding our far field patterns onto the window. We can see here that the first characteristic mode of this object has a dipole-like shape, and we can change the frequencies here as well as the mode index. Finally, we can look at electric field, axial ratio, and handedness, and we can look at it in dB. This has been a demo of Altair HyperWorks FEKO using characteristic mode analysis.